Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So for this video, I will share with you about 2D computer animation. Alright. And the course outline for this chapter is what we call as Translational Keyframe animation. So basically for this part, it's a revision on the previous chapter, and I have also add few informations on the keyframe animation. Alright, and then in this chapter we also will look into 2D transformation in 2D computer animation, such as translation, rotation, scaling, reflection, and shearing. Alright, so now we start with our first part for this chapter, which is for the keyframe definition. So keyframe definition is a drawing that defines the starting and ending points of any smooth transition. So between these two actions, there is an in-between action. Alright, so the drawings are called frames because their position in time is measured in frames on a strip of film. Alright, a sequence of keyframes defines which movement of the viewer will see, whereas the position of the keyframes on the film animation, a film video or animation define the timing of the movement, because only 2 or 3 keyframes over the span of a second do not create the illusion of movement. So the remaining frames are filled with what we call as in between. Right, so in-betweening is a creation of intermediate frames between the keyframes. It is created to control how the objects will change over a sequence of frames. Alright, so if you look into this example here, our keyframe is this point, first one, this is the second one, and then the third one. So these are the main movement for this scene. So from keyframe 1 and keyframe 2, there is another sequence of movements, and this is what we call as in between. Alright, there are 4 possible elements that can be twinned. So we can do the twinning in terms of the size, the positions, obviously, the rotation, how it rotates. This is a good example here. Alright, and then also object color. So if you look into this example on your right here, in terms of size, you can see there is a difference of size from the keyframe 1 to the first in between frame here, and the first in between and the second in between, more or less the size, we can say it's equal. Alright, same goes to the third in between, fourth, and then from the fourth in between to the second keyframe, the size is different. Same goes to the position. From the keyframe 1 to the in between frame 1, the position is different. Alright, so on so forth. About the rotation, obviously also different. Alright, if you see the rotation from the keyframe 1 here to the in between frame 1 here, there is a difference in terms of the rotation of this ball. Okay, and same goes to the color as well. Alright, but for the color it is not so obvious, but we also can see here, okay, where the color in between frame 2 here. Alright, you can see the red color here is more dark compared to the first in between frame. Alright, how to create in between frames. So existing animation software such as Blender and Maya have several ways to create the in between frames. One of them is by employing the interpolation transformation. Okay, so interpolation transformation means that we apply the mathematical equation. Alright, the simplest interpolation is the linear interpolation approach. Alright, now we move into linear interpolation part, linear interpolation creates a uniform rate of change between keyframes. So if we look back into this example here, all right, into this example here, so if you notice for the interpolation, we will aim on the keyframe. Alright, so in this example, if you look into here, we can say that the movement of this example here is basically using the linear interpolations, because the rate of change from keyframe 1 to keyframe 2, keyframe 2 to keyframe 3 more or less are equal. Alright. After Effects interpolates the values between two adjacent keyframes as directly as possible without accounting for the values of other keyframes. If linear interpolation is applied to all keyframes of a temporal layer property, change begins instantly at the first keyframe and continues to the next keyframe at a constant speed. So a change from one keyframe to another keyframe will be equal. Alright, especially if you set from beginning. Alright. At the second keyframe, the rate of change switch immediately to the rate between it and the third keyframe. When the layer reach the final keyframe value, it will change stops instantly. In the graph, the segment connecting two keyframes with linear interpolation appear as a straight line. So as the name here linear, then you can imagine that the change not the change, but this interpolation, if we translate it into a graph, all right, into the xy graph here, then we can say that it is straight line. Okay. So example of linear interpolation equation is x equal to x0 plus this is the time rate multiply with the x1 and the end point minus x0. So t0 is the start is the start time, t1 is the end time, x0 is the start key, and x1 is the end key. Alright. Okay, so this is the example, this is the formula of the linear interpolation. So the disadvantage of linear interpolation in between. When we talk about the advantage of the linear interpolation, it's simple. Alright, so one of the advantages of linear interpolation is it's simple to be applied. Alright, but in terms of the disadvantage of linear interpolation, not all animation you can use the linear interpolation. It really depends on what kind of a movement you want to make in your animation. Alright, so if let's say you apply the linear interpolation in all animation, so it may lead to shrinkage. Okay, when interpolating rotation, and it can also cause unrealistic movement. Alright, so this is the difference between linear interpolation, which the straight line here, and the Hermite interpolation. Alright, so perhaps this is the difference. So you can see the linear interpolation it will provide you with a straight line. Okay, whereas for the Hermite interpolation, another type of interpolation, it can give you more curvy movements. Alright. Okay.